In high-energy particle physics experiments, physicists use particle detectors to detect tens of thousands of position measurements of particles, or space points, and use complicated tracking algorithms to put them into groups, or tracks. So, the current algorithms have gotten pretty good results so far, but the algorithms aren't efficient enough to be sustainable into the future. But we can make the task of particle tracking faster, smarter, and cheaper with machine learning. One machine learning algorithm is decision trees. If I want my computer to be able to visually identify chocolate, this makes chocolate my signal and everything else background. There are two main parts to any machine learning algorithm: training and testing. In machine learning, training is used to teach a computer how to organize data. Here, we tell it to divide the sample based on shape. You can calculate the purity of a leaf by dividing the number of signal by the total number of events. Here, we have 1 out of 2, or a purity of 50%. Purities are what we use to measure how good a decision tree is. We can use color to narrow down this leaf, but not the other. Instead, we use the letter painted on the candy. This is a tree with 3 branches, or nodes, and 4 leaves, with the following purities. This is an excellent decision tree. Now that our decision tree is trained, we can test it to classify an unknown event. In particle physics, the measurements in one track are the signal and everything else is background. Real decision trees like the ones that physicists will use will have a lot more than 3 nodes, and they probably aren't going to have purities as perfect as ours. But using programming, you can try a whole bunch of decision trees with different combinations of variables at different levels to figure out which decision tree is best for separating your signal from background. There are lots of ways to complicate and improve decision trees, and there are also other machine learning algorithms like neural networks. But by combining our knowledge of machine learning and particle physics, we can completely revolutionize the process of finding track trajectories. And machine learning isn't by any means just particle physics. It can be used to analyze and organize literally any kind of data, being useful in things like facial recognition, or even organizing your Twitter feed to make it funnier for you personally. By using decision trees and other machine learning algorithms, we can cross monumental milestones that will bring us into the future of science and technology.